Have you ever wondered how researchers make decisions about their data? Today, we unravel the mystery behind hypothesis testing. Hypothesis testing is a statistical procedure that helps researchers make informed decisions. At its core lie two essential components: the null hypothesis, denoted as H0, and the alternative hypothesis, denoted as HA. The null hypothesis is a statement that suggests no statistical significance exists in a set of observed data. In simpler terms, it assumes that any kind of difference or importance you see is due to chance. On the flip side, the alternative hypothesis challenges the null. It proposes that the observed data is not due to chance, and indeed has statistical significance. Hypothesis testing plays a pivotal role in research, helping to validate or refute assumptions and shape conclusions. Understanding these hypotheses sets the foundation for the steps involved in hypothesis testing. Now that you understand the hypotheses, let's delve into the step-by-step process of hypothesis testing. First, we state the null hypothesis and the alternative hypothesis. The null hypothesis suggests that there is no significant difference or effect between the variables we're examining. The alternative hypothesis, on the other hand, posits that there is a difference or effect. Once we have our hypotheses, we collect data. This data must be relevant to our hypotheses and gathered in a way that minimizes bias. Next, we calculate the test statistic. This is a numerical value that helps us understand the relationship between our data and our null hypothesis. Then we determine the p-value. This value represents the probability of getting a test statistic as extreme as ours, assuming the null hypothesis is true. Finally, we make a decision. If the p-value is less than or equal to our predetermined alpha level, we reject the null hypothesis. These steps guide researchers in making informed decisions about their data. Hypothesis testing is not foolproof. Errors can occur. Let's discuss them. Type 1 error, or a false positive, happens when we reject a true null hypothesis. On the other hand, type 2 error, or a false negative, occurs when we fail to reject a false null hypothesis. These errors can have significant consequences in research, potentially leading to incorrect conclusions and misguided actions. Being aware of these errors helps in understanding the limitations of hypothesis testing. Despite the possibility of errors, hypothesis testing wields significant power in research. Let's explore why. The power of a hypothesis test is essentially the probability of correctly rejecting a false null hypothesis. This power can be amplified in two ways: by increasing the sample size, giving us more data to work with, or by increasing the effect size, which means making the difference we're trying to detect more pronounced. Hypothesis testing, when used carefully, is a powerful tool in making informed decisions in research. So there you have it. That's the process of hypothesis testing in a nutshell. We've unraveled the mystery behind null and alternative hypotheses, where the null hypothesis is a statement of no difference or effect, while the alternative hypothesis suggests a difference or effect. We then walked you through the crucial steps in hypothesis testing, starting from stating the null and alternative hypotheses, collecting data, calculating the test statistic, determining the p-value, and finally making a decision. We also highlighted the possibility of errors, type 1 and type 2. Remember, type 1 error is a false positive, and type 2 error is a false negative. Lastly, we talked about the power of hypothesis testing, which is the probability of correctly rejecting a false null hypothesis. This power can be increased by enlarging the sample size or by increasing the effect size. Remember, understanding hypothesis testing contributes significantly to making informed decisions about research data.